Hi, geometry. So this is homework number 4 from slide 29. So this is your first coordinate geometry proof, and we're just going to walk you through on how it's done. So the given here are the coordinates that are also listed here on the coordinate plane, okay? So the given is these ordered pairs, right? And the proof is the quadrilateral FGHJ is a parallelogram, okay? It's the first thing I'm looking at by showing, so you're going to prove that the parallelogram is a parallelogram by showing that opposite sides are parallel, okay? You have to know what a parallelogram means, and you need to know like how you can prove that something is parallel. So I know that a parallelogram has two pairs of parallel sides, okay? And when I'm looking at this, I see that this side and this side have a negative slope, and I see that this side and this side also have a negative slope, okay? So my two pairs of parallel sides are this is one pair, and this is the second pair, okay? So now, choosing between the slope, midpoint, or distance formula, how do I prove that the opposite sides are parallel? Well, I'm going to use the slope formula, okay? And as we recall, it's m equals y2 minus y1 over x2 minus x1, okay? So you guys will see these annotations. This is the slope of f to g, the slope of j to h, the slope of f to j, and the slope of g to h, okay? Typically, this won't be written out for you, but since this is your intro video, we went ahead and did that, okay? So that's how I was able also to point out, like, so f to g is parallel to j to h. That's why these two are together, okay? F to J is parallel to G to H, F to J, G to H, okay? So I'm gonna go ahead and identify always my X1, Y1, X2, Y2. So since F is listed first, I'm gonna write -1, 5. That's my X1, Y1. And G is listed second, so that's 3, 3. X1, that's my X2, Y2, sorry. And then you're going right ahead and plugging into the formula. Y2 minus Y1 over X2 minus X1. So it's going to be 3 minus 5 over 3 minus -1. 3 minus 5 is -2. This turns into addition. That's 4. So my result is -1 over 2. Okay, that's my slope for F to G. Now to prove that they're parallel, they have to have the same slope. So -1 over 2 should be the same answer here. Again, doing the same. The coordinate for J is 2, -2, as I can see right there. 2, -2. And then the coordinate for H is 6, -4. X1, Y1, X2, Y2. Okay? And then we're just plugging in for the formula. So we get -4 minus -2 over 6 minus 2. This turns into addition. I get -2 over 4, which results in -1 over 2. So I can already tell, right? I have 2 minus signs here. So the slope for here is -1 over 2, because that's F to G. And the slope for down here is also -1 over 2. So I just proved that one of the parallel sides exists. Now I have to go ahead and prove it for the other two, okay? Starting again, F is -1, 5, and J is 2, -2, X1, Y1, X2, Y2, plugging in for the formula, -2 minus 5 over 2 minus -1. What do I get? I get a -7 over 3. I can't simplify any further. That's my slope for F to J, okay? So since these two sides are parallel, I have to prove that these two answers are the same, okay? That's Oreo, okay? So 3, 3 for G and 6, -4 for H. X1, Y1, X2, Y2, plugging in for the formula. Guys, we're just repeating the same steps over and over. We just want to make sure we get the same slope. And this is how we prove that the slopes are the same through our math work, okay? So -4 minus 3 over 6 minus 3. This gives me -7 over 3. Chacarang. I just proved that f to j, the slope is -7 over 3. And then g to h, the slope is -7 over 3. So now, I showed all this work to prove that the two sides are parallel. Now I'm going to make a statement. So the opposite sides are parallel because the slopes are equal. Okay, hope that helped. If you need help with this question, please make sure you come to office hours.